All right, good afternoon, everyone. I'm really happy to be here to present you this topic right here is about three-dimensional security and how we leverage graph and search to approach a security and compliance problem and automate security and compliance. My name is Erkang. I'm the CISO for Lifomic. I've also founded a product called Jupiter-1, which is a security product. What I'm here to talk about is how we used this technology behind the scenes. This is how we operate security at Lifomic, how my team does automated security operations and compliance, as well as the technology behind the scenes for Jupiter-1, the security product that we built. Now, before I start, I want to draw your attention to this is what I'm going to cover. I want to talk about, what is the root cause of, all evil or everything that's wrong today in the cyberspace, and what I mean by two-dimensional security and what I mean by three-dimensional. And I want to give you a demo and do a little bit of a Q&A session at the end of it as well. So I'm sure that everybody has heard of all the breaches, right? And I'm not here to bore you with that. But I want you to kind of keep this in mind and think, what do you think is the cause of these cyber breaches? Why do they keep happening? We know it's not going away. It's just going to keep happening every day or every week. You're going to see something in the news. But why is that? We make this a little interactive. Anyone? What do you think?
I think it's organizational commitment is the core of it. It's not getting the resources and attention.
Resources, right? So resources, attentions. Oh, one sec. Let me turn this back on. Well, there are probably many things, right? So you may hear people say that, okay, it's because of the users, right? So you can't fix stupid. Somebody's going to do something dumb. Well, maybe. Now, somebody may say that it's because security is not compliant, right? Because, all of the companies that were breached, they're compliant. They're PCI compliant, they're certified, and whatever. But they still get breached. So sure, yes, that is true. Security is not compliant. Or it could be that, the organizations that they foundationally just lack good security hygiene. They're not covering the bases and so on. And of course, like this gentleman up front mentioned, it could be that just there's a lack of resource, right? Just the good guys, the defenders, they just can't keep up. There's so much happening, and the defenders, we have to do everything right all the time, and the attackers only have to do one thing right, that once. But I will still ask, why is that? Are those the root cause? If there's one thing that you want to think about, that is the root cause, even behind these, what is the reason? Why is this so bad? Why can't we let the users do what they want to do? Why is security not compliance? Why is it so bad that the defenders have to do everything right? And what's causing that? Now, there's one thing, and that one thing is complexity. That is what drives all of the problems that we see today in our digital environment. And that is the reason why the defenders couldn't keep up. And that is the reason why we cannot have continuous security and compliance. It's not that we don't want it. It's not that we don't understand that we need it. It's just the complexity inhibits the ability for us to get there. The complexity is driving us so that we do not have the right visibilities. We do not have the deep visibilities. We're barely scratching the surface into what we have. Now, I want to ask anyone here to think about your organization and the resources, the assets, the data, and the entities and everything that you have in your organization. Now, who here has a complete picture and a deep understanding of everything that's going on right now in your environment? Nobody, right? I don't think anybody can really claim that. It is a difficult problem. It is the complexity that drives all of the reasons behind why the breaches keep happening. And that's also why the defenders, the analysts, they cannot respond to the incidents quickly. There's just so much to analyze. And there's so much alerts, and we have alert fatigue and so on, that prohibits us from focusing on the very meaningful tasks. And all of these are what? They are advantages to the attackers. So knowing this, what are we going to do? How do we solve this root cause? Right? So the security industry is very good at doing one thing. It's throwing tools at problems. When we have, we know that things that happen with users, right? And we know that the boundary is no longer at your corporate network. What do? We come up with a solution called MDM, Mobile Device Management, or EMM, right? Enterprise Mobility Management. When we say that our firewalls are not good enough, they're not blocking things at the right, layer 3 attacks, we have, what do we do? Next generation firewall. Every time there's a problem, boom, there's a tool. Or what's the other way to do it? Add some resources. Add another expert to manage this system. What does that do at the end of the day? It adds complexity. So this is a never-ending loop of not solving the root cause. Well, if I say this out loud, it seems simple and logical. What do? We have to do two things. And number one is that we have to understand the complexity that we have. We have to truly understand in a way that we're able to track and see and analyze our environment as a whole and everything that goes on in the environment in what I call 3 dimensions. I'll get to that point. And second is we cannot continue to add complexity. We cannot continue to throw tools and processes and people at this problem. It doesn't help, it hasn't helped, and it never will. And what we need is more automation. Well, this is simple, right? This is easy to say, but how do we do this practically? Now, keep those two in mind, and I'll move on to the next topic, which is what I mean by 2-dimensional security. This is actually pretty easy to correlate and to understand. And take any compliance framework, take anything that you're doing today. It is a checklist-driven approach to operational security. You have certain things in your environment. It may be a user, it may be an endpoint, it may be an instance in AWS. That's your first dimension. The second dimension is, how is that configured? What is the user doing, right? So those are the second dimensions, the configurations and your resources. Now, if they are configured according to your policy or according to the compliance requirement, check. That is the current approach. And from an assessment standpoint, from an audit standpoint, that's a survey-based approach, and assessor will come in here and look at this list and see if you're doing what you're doing. And again, this is this very 2-dimensional approach to security. Now, what does this do? This is not unnecessary. This is great. This is a good step forward, but it answers one set of questions. It answers the what. It answers the what you have, how is it configured, and the what questions. But what it doesn't answer is the so what. So I'll give you an example. If you notice that a user, an employee of yours or a user account that does not have multi-factor authentication enabled, is that good or is that bad? Maybe. I don't know. Well, it really depends. So that is the 2-dimensional approach, is to say, okay, of course, it's probably bad, right? We want users to have MFA enabled. This is so fundamental now. Everybody should, right? If you don't have an MFA enabled in your user, you should probably just stop listening right now and go do that right now. But on the other hand, is it really a drop everything and fix it type of problem? You don't know until you dig further. If that user is in a sandbox demo environment that is contained and has no access to anything else important, maybe it's intentional. Maybe it's not that big a deal. If that user is an admin user that has access to a production environment, of course, you better drop everything to fix that right now. So what it lacks is this third dimension, which is the context and the relationships in your environment. What's connecting the dots in your environment? And that's what's lacking. And that's the problem is today that makes the attackers win. As you see here, the attackers, they think in graphs. They think in this kind of connected model. And the previous session talked about red teaming, and I'm pretty sure that's what they think about, is how one thing leads to another. Right? Once they gain access to something, how does that become a beachhead for them to elaborate their access or elevate their privileges to gain access to anything else. They think in graphs, but defenders, they think in checklists. And that's why attackers win. And that leads to the main topic today, which is how we use graph and search to address this problem. So when I say graph, it is not pictures, but it is this computer term graph is a label property graph, more specifically, that represents ideally everything that you have in your environment. Now, if not everything, or most everything is good, right? Multiple aspects of your digital environment and your digital operations. That includes these following things. Your infrastructure, for example, your AWS accounts, the resources within your AWS accounts, your development environments, your developers, your source code repos, and your end user devices, and what they have and how many trainings they've received, and so on and so forth. The applications you have in your environments. And of course, the security controls and findings, like identity and access management tools, your security scanning products, your security agents, servers and endpoint agents, and so on and so forth. Now, that's what I mean by this graph model. We'll go deeper into that. And what this graph model has, and this is what we've built for our internal operations and Jupyter-1 as well, is a set of entities and relationships. When I say entities, the entities is a node, a labeled node in the graph, a vertex in the graph that represent, each entity represents a single resource within your digital environment. It could be a user, it could be a person, an employee, it could be an access key, it could be a data store, a workload, and things like that. So there's a whole set of entities that would represent your environment. Now, each entity has its set of properties, and these properties represent its state and its configurations. There are some common entities or common properties that would apply across all entities. Here are some examples of those. For example, the name, the display name, how they're displayed, and the summary, description, classification, risk, status, and so on and so forth. And there are a set of other properties that represents the status, whether it's active, if it's publicly accessible, if the resource has been validated, if it's temporary, a set of timestamps, a set of tags and nodes associated with all of those entities. Now then, specific entities would also have their own specific properties. I'll give you a couple examples. I won't go through all of them. Like a data store. A data store could be in the form of an AWS S3 bucket, a database instance, or a EBS volume. It could be a type that is entirely not in the cloud. It could be an on-prem file server as well. And so certain properties associated with that could be the location of it, whether that data store requires encryption, and the actual encryption algorithm, the reference to the key, whether it is encrypted, and whether it's public, and so on and so forth. And some other examples, a function, right? A function, a serverless function can be a Lambda function, Azure, or Google Cloud function, and each one of those would have its own set of properties like image, version, runtime, and so on and so forth. A couple other examples like host, right? These are pretty self-explanatory, and a person, it's got the first name, last name, email, address, title, and those type of things associated. Right? So once we have a set of these entities defined in the graph, these are, you have your two-dimensional view, right? So you have your resources and you have the configurations of them. Now we're moving on to the third dimension, which are the relationships. How we define relationship in this data model is a set of abstract verbs, right? So these are verbs that are generically describing what those resources are. Very similarly, I forgot to mention that these entities previously that you saw, there's the type, but there's also the abstract label class for these entities, like data store is the label, and the S3 bucket is the actual type of that entity. The relationships are these verbs. For example, an AWS account has AWS instances, right? So that represents the relationship. Or a VPC, or a network within AWS, contains subnets, right? So that's another different set of relationships. Some other example would be a user is a person. A user that represents a digital user account is actually the employee or that person. These are some of the examples. Now, you can also have things like a vulnerability that exploits or an attack that exploits a vulnerability which impacts an application or a code repo, right? So you can continue to chain and to connect the dots using these relationships. So I'll give you a couple examples. Here's a simple one, which is, in this example, there are 3 users. Okta is an identity provider. You can have an Okta user that is this person. You can have a GitHub user that is also this person. Or you can have a IAM user in AWS that is also this person. So this is a 1-degree relationship, right? Now, let's expand this a little bit and see what else you can see from these relationship map. Now, what you see here is that the Okta user is assigned a multi-factor device and access key. And you can also see that the IAM user is assigned a MFA device, but it also has, that user also has a key, which is an access key in IAM. You can also see this example that there's an access role, an AWS IAM role that belongs to a different AWS account that trusts this IAM user here. So from this simple example, you can already see the extent of how you can kind of drill down and extend the relationships and use this as an analysis tool for understanding what you have and the complexity of your environment. Now, at this point, you may be thinking, well, this example is actually extremely simple. Now, there are many things that are connected, right, in this complex environment of yours. How big can this graph really get, right? Well, we've actually done some analysis of actually some of our customers and our own users. So we've done some benchmarking on some of the data that we've collected. Now, for a small organization like a very small startup, 5 employees, a single AWS account, there could be 340 plus entities in this exact example and over 1,000 relationships. And up to a huge enterprise with thousands of customers or thousands of employees ends up with 250,000 entities and over 1 million relationships. And what does that look like? I'll give you an example. What does this look like? This is a very specific example graph with 1,348 entities and close to 3,000 relationships. The graph looks like that. How do you understand this? But that is the reality, right? This is a fairly small organization. This is the reality of what we're dealing with. That's what we have in our environment. Now, try to make sense of this yourself, in your head. It is near impossible without some tool to assist you to understand the full context of what's going on. And not to mention that in today's cloud environment, things change constantly. What you just understood a minute ago could have changed the next minute. So how do you keep up with this complexity? So first, right, so we've established that now there's a way, right? If we can build this graph, that's great. This graph represents what we have. The second challenge is then, how do you understand it? That brings me to the search. And this is what the attackers do anyway. What they do is they focus on a subset of your environment to analyze the subgraph. So we have to have a way of querying and searching the graph in order to come up with a subgraph that you can focus on and get a deep understanding of that particular subset. So what's the end result of this? The end result of this, I'll show you in the demo some examples of how this works. But the end result of this is you can then operate security and compliance as simple as asking questions. So imagine a Google-like experience. You come to one place, and this place has the entire understanding of your infrastructure and your environment all you got to do is ask those questions. Questions like, who has access to my data? Who has administrative access? The users with admin access, do they have MFA enabled? Are my devices encrypted? Are my data stores encrypted? Right, those type of questions should be easy to answer and should be easy to analyze if you have the full graph and you have a capability to search and query that graph. So what else can you do with it? Right, so once you have that, then there are a lot more advanced analytics and automation that you can do. I'll mention a couple of use cases here. One is you can automatically determine the ownership from events. And when an event comes in, you can capture from that event information the principal that triggered the event and assign an implied owner of the resource that that event impacts or it creates. An example being AWS CloudTrail events. When you have a create incidents event that came from CloudTrail, and that event is associated with a principal, and you can kind of determine implied that user who created that resource is probably the owner. You can do event correlation based on the validity of the existing context. So this is a far better approach than using SIEM, right? So SIEM, Security Information Event Manager, because what you have right now is a persistent context. You always know what you have, your current environment. When an alert comes in, when an event comes in, you can always correlate, not just to some other random events that may happen within that window of time, but what you currently have. What is the current state of your environment? You can do alerting based on the risk level. You can do individualized alert notification. You can do automated vulnerability management and use this as part of your DevOps pipeline as gates in your deploys. So there are many things that can be done now with this type of analysis and automation. How do you build something like this? Right, so how did we build something like this? And this is what's behind the scenes of the tool that we've built. Well, there are at least a few things that you're going to need. Right? So these are the 5 things. There's probably more than that, but these are the high-level things. You're going to need some sort of a graph database. Right? So this is a graph behind the scenes. You're going to need a way to get data in here and continuously get the data in here. And you're going to need a way to find the data, to query and search, like I mentioned before. And you're going to have something to visualize it. And then at the end, these advanced analytics and automation that I mentioned, you're going to need some sort of a workflow integration to enable those. So let's talk about each one of those in a little bit more detail. The graph database. Well, there are many options out there. So here are some examples. Neo4j is probably the #1 popular one out there. And there's a couple of open source solutions listed here, Janus Graph, OrinDB, and also Amazon Neptune, which is what we use for our product. Now, what about getting data? This is very tricky. It seems like it should be simple, right? All of these are cloud-enabled, SaaS-based solutions. There's APIs. Why don't we just write some scripts and talk to the APIs and ingest the data? It sounds simple. It sounds easy. But in reality, it is very challenging. We've been doing this for over a year now, and it is very challenging to get done. So you have some components like this, right? You have your data source, some APIs that you talk to. You have your ingestion via some sort of integration to convert the data and synchronize the data into the graph, and which is triggered by some sort of scheduler on a time-based window or a trigger by certain events. Well, cool. And then you have to have some component to persist the data to your graph, or maybe capture that additional ancillary data in some sort of a raw data storage, either in S3 or some other form of data store. Now, you also need to have a component that can do the analysis of the relationships and map out the relationships, not just within a single environment itself, but more importantly, across environment, like resources, how is one resources from one AWS account relates to resource within another AWS account? What is that cross-account relationship? How does users within Okta relate to users in your AWS environment? How does your code repos relate to your projects or your application that you deploy into your cloud environment, and so on and so forth. These cross-environment relationships needs to be mapped out. Some of the challenges that we saw, like I mentioned, is not that trivial. One is we got to get the data right. And we have to get it right not just one time. Getting it in one time is fine, but we have to do it consistently and continuously. There's a lot of the updates. We have to make sure that every time something changes, we need to be able to update the data in the graph accordingly and accurately. And when things are deleted, right, when things are created, right, all of those changes, the diffing process is pretty complicated. Now, there are specifics from the data provider we'll have to consider, like rate limiting, the authentication model. Is it using API keys? Is it an app that we have to install in the providers, like a GitHub app? Right? Or is it using assume role, like in AWS, the assume role trust relationships, and so on and so forth. So all of those has to be figured out. And of course, the compute resources required to analyze the environment, especially when it comes to serverless. There are limitations on how long a Lambda function can run, and so on and so forth. And there are details that come from an entity may come from multiple resources. How do you map all of those details of one particular resource that may carry information from different providers? Like a host is a good example. You may have various type of host agent that contains information about this host device. How do you aggregate that information from different entities into one? Right? All of those are challenges that we had to solve. And of course, data migration when the time comes, and the fact that there are just lots of different data sources and integrations to cover the scope that you may have. So this is getting data in. And then finding data. Now, once you have this data in graph, and you may also have this data in an index, how do you find this data? There are two ways that you need to analyze this data. One is a structured way that you can analyze the entities, their properties, and their relationships. Well, it depends on the graph database. This could be done via either the Apache Gremlin language, or Sparkle, or Cypher, which is unique to Neo4j. Those looks pretty complicated, as you can see from this particular snippet there in the box. Now, of course, there's also unstructured query. Now, you need to be able to index your data, the properties of those entities. You need to be able to do a full-text search, and you may need to be able to query the raw data, the raw events that you've ingested. All of these are very challenging. And what's more is you may be able to do this individually and independently. How do you combine them in a meaningful way so there is a intuitive, easy-to-use search language, but also precise? This is more difficult than a search in Google, right? Because what you're looking for in Google is you type in some search terms, there are a bunch of results, you can analyze those. But in this particular case, you are driving alerts, you're driving your compliance evidences based on those query results. It has to be precise. At the same time, it has to be flexible. Well, we'll show you an example later on. Now, once you have this query language, how do you display that, right? You need to be able to visualize the subgraph, right? Visualize the results. There are a couple things that you can do here. With Neo4j, they provide a browser that you can use to look at the data. And there's various type of software that are basically graph viewers on top of graph databases. Or there are JavaScript components that you can use to write your own. We actually did our own with some of these components. The last thing is this integration with workflow and automating the workflow. So what can be done here will be a set of rules, alerts. Now, there needs to be an engine that supports rules and alerting. And there needs to be integration with things like Jira, create a ticket, update a ticket, send notification to Slack or email, of course, or paging somebody when an incident happens with PagerDuty, and maybe even automatically trigger security scans of a scanner as part of the vulnerability automation. So these are all the things that needs to happen in this graph-based security tool. right? Makes sense? So now with that, I'm going to try to do a live demo. Let's see how well this goes of the platform. So this is what we built, and luckily that of course, as I mentioned, you can totally do this on your own with those 5 or 6 different things I mentioned, and we've actually released this as a SaaS product for anyone to use, and of course it's not completely free, but you also don't have to build it yourself. Now, again, the idea is to make this simple, right? To make security a search problem. This is why when you first come in here, you just present a search bar. You can start typing things and find things in there. But before I do that, I want to just show you real quick, what data is integrated in here that you can look for stuff. Now, this is our own account on Jupyter-1 on this security platform. We've integrated 6 of our AWS accounts, a Bitbucket account to a couple of GitHub accounts and Okta and Veracode, and this is the extent of our integration so far. Now, once these integrations are configured, I just want to show you real quick the assets that are brought in. Right, this is the 2-dimensional view of the things that we have. So I'll draw your attention real quick to the lower right, and there's a count, and there are nearly 8,000 assets or entities that are ingested automatically from these integrations. Now, this required absolutely no manual effort, and there required no manual entry of any of these nearly 8,000 data points at all. Now, each one of these is associated with its own set of properties that you can see the details of them. And they're also labeled accordingly for their class. Like I mentioned before, there's things like database. You can filter on these classes, and you can see that these are the different types of databases that were ingested, right? So these are the specific types, and labeled with the abstract concept of this is a database. Same goes for users. I think these are users right here. You can see there are Okta users, Bitbucket users, GitHub users, IAM users, and so on. Now, they each have their own properties associated, right? So again, this is the 2-dimensional view of the things. Now let me go back to showing you the more interesting ones. Now, what can you do when you start asking questions? Like one example would be you can just start typing in things in here and say, okay, are there SSH rules? What are the inbound SSH rules in my environment? Now I'll show you all of these, and you can see this in a graph view. And this is the subgraph that you can start to analyze. You can see, okay, this is how the SSH connections are happening across the thousands of entities within 6 different AWS environments that we have. Another example would be EC2 instances, right? So other EC2 instances connected to the internet. And again, here are the instances returned. You can see this in a graph. And as you see here, there are a security scanner, and there are some VPN servers exposed to the internet, right? So this is a way for you to see in an interactive way what's connected and how things are connected in your environments. This particular one is a security group, right? You can see the some of the properties associated with that. And you can actually interact with this graph, and you can expand it and see what else is connected within the security group, right? So this is, again, is a way for you to see and understand your environment based on simple questions and queries. Any questions or anything anybody's particularly interested in maybe seeing?
So if you're looking at EC2 instances to, let's say, EBS volumes, how would you correlate those two together?
Well, so the question is, how do you correlate EC2 instances and the EBS volumes, right? So now these are the questions I typed in and I was asking by just typing the keywords. I'll type in something specific, like find AWS EBS volume. So this simple query right here, it starts with finding all the volumes. And also to add on to your question, maybe you might be interested in saying, okay, are there volumes that are not encrypted, right? So I can actually extend this query and find things like with encrypted is not true. And it should hopefully return me a subset. Oh. In the environment. So you know, these are some of the well, hopefully this is correct, right? There are a bunch of entities that are in here, the volumes that are not encrypted. Now, well, to your second part of your question is how does that relate to the instances, right? Now you can do things like find AWS instance that uses AWS EBS volume. Now this will just find the instances that are using these volumes, right? And again, you can see this in a graph and see how they are connected, right? So this one is, there's a lot of them right now, and you can see how these instances are using these volumes. Now you can also see that, you know, I can reverse this query and I can actually find EBS volumes that are not being used by anyone. Now this will find me, you know, volumes that are not being used by any instances, right? So you can use kind of simple queries like this to analyze your environment and find, you know, misconfigurations and understand the relationship across the board. There's no limit to how many verbs that this supports. It's driven by the data model that's defined, right? So when the data is ingested, that these relationships are mapped out using these verbs. So as long as that relationship has that verb label, you can query using it, right? Because, you know, for example, you can actually do things like find. I'm going to use an example in here in our Bitbucket account. Find Bitbucket user that is not person, right? So here's an example of how you can find user accounts that are not mapped to interactive users, right? This must be a system user of some sort or an API user of some sort, right? And you can also do things like, you know, find users that have assigned MFA devices and things like that, or, you know, admin users, right? You know, who has been assigned admin access. You know, those type of things that you can also query in the environment. So, and again, this really depends on the amount of data ingested and the amount of integrations that is within this environment. The more there is, the more powerful that you have and the more visibility that you can gain into your environment. Some other questions? Now, there's also a set of, here's some examples of all of the questions that we can ask, right? These are just some template examples. There are many things, right? You can find things about your users, you can find things about your applications, you can find things about your networks, and even your employees, right, who are the new hires, and other IP collisions in your environment. So this is not entirely limited to just security analysis. You can do operational and network type of analysis of your environment as well, right, using these questions and queries. Any other questions? Is there any other thing that you might want to see as a query? Yeah.
If I'm a new user, and how would I find, I haven't memorized all the relationship names and everything. Can I get help to find out what's available for a person?
Yeah, you can do a couple of things, right? So, one thing is there are some designated entities that you know. One would be the root. The root is your root organization. Now, when you do this, you can start exploring, right? So that's why the graph is interactive. You can start exploring what you have, right? So this expands into different accounts and different users, right? That's one way, and you can just do these kind of generic things. You can do find account, and you can again, just navigate a graph, right? By expanding the graph and start seeing what relationships there might be in your graph, right? By navigating these graphs. As you can see here, then these relationships are highlighted, so you would see what those relationship verbs are, right? So here's an example that says trust. Make sense? Oh, yeah, so the question is, can you do a query like find anything that trusts anything? Sure. This may take a little longer to run. Let's see. Could be a pretty massive graph. There's a lot of trust going on in the environment. Come on. If it doesn't work, it's your fault. Oh, it didn't work. There's too much going on. Right. What we can do also to make this a little easier is this. Right. So we can do find access row that trusts something. Oops. Let's do this in an easier way. There's a lot, right? So yeah, so there's a lot going on, and which does show you there's a lot of data behind the scenes, and there's a lot of relationships going on behind the scenes, right? Well, with this amount of data, close to 8,000 entities, there's probably 30 or 40,000 relationships going on in this environment. That's a good question, right? How does data get updated over time? So the primary way today that data get updated in the platform as is right now is on a schedule, right? So every 30 minutes or so, it will go retrieve data from the source environment for each integration, and it will do a comparison to see what changed and update the graph and update the properties and create new entities, update entities, and update relationships and so on. Now, what we actually are actively working on is to make that event-driven, right? So remember, I showed two triggers to the integration. One of them is the schedule, and the other one is events. So what that means is we're going to ingest events like CloudTrail events and security alerts, and use that as a trigger for updating the graph, right? So get the context from the event and get additional context from API calls to update the graph. Yeah. Sir, and then another question?
Yeah, so like in a SIM environment, there might be some kind of a property ID or resource ID that is thrown as an event. Can you do any search for that stuff?
Right, that's a good point. So let's see. So an ID, right? So let's just say in an event, you saw an event with this ID in there. And the event itself may not have enough information to show, okay, what is this about, right? So all you got is an ID. So what you can do is this, I mentioned this full-text search, right? So you can simply enter this string, and it'll find exactly that item for you based on that ID. And then, of course, you can, if you want to analyze it as part of, say, instance response, right? If this is part of the source that triggered a security alert or triggered a security incident, you can start seeing this, and you can start expanding and see the relationships that this entity has from that point on. Now, this can also be combined with the rest of the query, right? One example would be, our developers do this all the time. We actually ingest certain information about the pull requests from the repos. So I can actually do things like, Charlie, which is a developer that opened PR. It'll show me the PRs that this person opened. Right? This is combining the full text search, right? Because I didn't have to know, Charlie has I don't know what his. I hope he doesn't mind me showing his information here out in the public. And this is his username is not Charlie, right? So, but what this did is basically a full text search, and it finds this entity and the relationship associated from that point on. Right. So the query language we've built is actually quite flexible. It allows you to search keywords and ask questions, and allows you to do full text search of any property values, and allows you to do very precise query using define something that has or that relates to something else, with that type of close to natural language, not exactly natural language, but feels like natural language type of query in a precise way. And also, like you see here, a combination of them right at the same place. All right.
You mentioned the possibility of integrating with a DevOps pipeline.
That's right.
Any examples that you demonstrated that?
I don't have a demo built for that, but I can describe how that works. Right. So we have ingestions with Vericode, for example, right? So which is a vulnerability scanner. You can come in here and do find vulnerability, right? So there are some vulnerabilities. These are the test ones. They're not quite real. But the idea is we have APIs, public APIs that's accessible for the platform. And by the way, I don't know if I repeat the question. The question is, how do we use this in a DevOps integration type of scenario? So the idea is to use Jupyter-1 as gates for your DevOps pipeline, for your deploys. So when you're doing deploys, we do this today with our Jenkins, and we would query the Jupyter-1 API and say, here's the code repo I'm deploying. Keep in mind that we have that integration with GitHub and Bitbucket. So we know exactly when you say this code repo, okay, yeah, we see it right here. And then you can just send the API a query and say, find vulnerabilities that impacts this repo, and use that, right? You can also do certain things like, width severity equals 5 or equals high or something like that, and use that as a decision point for your deploys, right? And what we're further building out, which is not in this current version right now, is a more full-blown vulnerability orchestration process, where within Jupyter-1, you can query things like, given a repo hasn't been scanned recently, when was the last time it was scanned? If it wasn't scanned, go trigger a scan. And if it has been scanned, what are the vulnerabilities? Right? Those type of, again, questions, type of interaction to help you drive a decision as part of your DevOps automation. Now, another benefit of that is we just went through this. We use a particular vendor, and then we are in the process of switching to another scanning vendor. Now, imagine that if you build a whole set of automation with certain tooling, right? And if you decide for whatever reason that this vendor is not working out, you have to switch to another provider, what would happen? You have to rebuild your automation. You have to rebuild your tooling. But in the case with integration with Jupyter-1, you don't have to, because we would abstract those interactions with the integrations between Jupyter-1 and those downstream controls and providers. You would have one place to talk to, and if you ever choose to change your vulnerability scanning tools, you don't have to do a thing but to reconfigure your integration in Jupyter-1. Everything else remains the same.
Is Jupyter
Alexa enabled? That's a good point. Yeah, that's something that we actually are looking into doing, maybe not right away, but sometime down the road, hopefully later this year, is to actually build a true natural language layer on top of the query. So you can come in here, it may be Alexa enabled, or you can just talk to it, through the web app and ask questions directly that way. Yeah, absolutely. Yeah, there's a lot of things that we plan to do, and that's on the roadmap of this. And we built this as our internal solution, and saw tremendous value that we're using. So we decided to say, hey, why keep it to ourselves, right? So let everybody else use it as well. So anyhow, so I'll just conclude, and the key thing is there is so much complexity. We have to have some sort of a graph-oriented way of understanding the environment, and some sort of a capability for us to search, query, and automate the knowledge that you gain from this environment that you have, right? So there's one thing that's pretty famous saying by the strategists is you can't protect what you can see, right? That's exactly what's happening right now with the cyber breaches. The complexity makes you not able to see and therefore not able to protect. All right. Thank you so much.